Hello friends, welcome to e-learning session on pressure sensors. In this video, we will see different types of pressure sensors. The demand for pressure measuring instruments increased during the same age. Pressure is nothing but force per unit area. In SI units, a force of 1 Newton applied to an area of 1 square meter exerts a pressure of 1 Newton per square meter or 1 Pascal. Any kind of pressure sensor contains a mechanism or structure that reacts proportionately to a force applied. The area over which the force is applied is constant for a given sensor structure. When pressure sensing technologies were first manufactured, they were mechanical and used Gordon tube gauges to move a needle and give a visual indication of pressure. Nowadays, we measure pressure electronically using pressure transducers and pressure switches. In recent years, pressure sensors have become digital, miniaturized, lower cost and lower power. These changes have increased sensor efficiency and performance. The applications are very vast across many industries in aerospace, automotive, medical, consumer, wearable, industrial, HVAC, home automation, and so on. Let us see working principle of pressure sensor. An electronic pressure sensor relies on a physical reaction to applied pressure and then measuring the resulting proportional change electronically. Commonly used phenomena include changes in capacitance or changes in ohmic resistance of the strain gauge or piezoelectric element, which are proportional to the magnitude of the deflection when pressure is applied. There are different types of pressure sensors: capacitive pressure sensor, strain gauge pressure sensor, piezoelectric pressure sensor, piezoresistive pressure sensor, and optical pressure sensor. Let us see first capacitive pressure sensor. A capacitive pressure sensor contains a capacitor with one rigid plate and one fixed plate. The fixed membrane and rigid plate membrane as electrodes. The area of these electrodes being fixed. Capacitance is proportional to the distance between the electrodes. The pressure to be measured is applied to the flexible membrane side, and the resulting deflection causes a change in capacitance that can be measured using an electric circuit. Advantages of capacitive pressure sensor. It includes or it needs only small force for operation and has a high input impedance. It has good frequency response and it is less affected by stray magnetic field. Disadvantages of capacitive pressure sensor are complex circuit arrangement, dust and temperature could affect its performance. Next, we switch over to strain gauge pressure sensor. In strain gauge type pressure sensor, foil or silicon strain gauges are arranged as a V-stone bridge. This is a passive type of resistance pressure transducer and its electrical resistance will change when it is stretched or compressed. A strain gauge is a wire which will change its resistance when mechanically strained due to physical effects. Strain gauge is connected to the diaphragm and when the diaphragm flexes due to applied pressure, the strain gauge will stretch or compress, and because of this variation in its cross-sectional areas and its resistance will change due to this, and this change is converted into voltage by linking 2 or 4 similar gauges similar to Wheatstone bridge so that the output can be maximized and reduces sensitivity to errors. The resulting signal is then amplified and conditioned to provide a suitable transducer voltage or transmitter current output representative of applied pressure. There are certain advantages of strain gauge pressure sensor. Those are, it is simple to maintain and easy to install. It has good accuracy and stability, fast speed of response, wide range of measurements, no moving parts, and high output signal strength over range capacity. Disadvantages are temperature compensation and constant voltage supply is needed. Also, electrical readout is necessary. Now, next is piezoelectric pressure sensor. Piezoelectricity is the ability of some materials, mostly crystals, to generate an electric potential in response to applied mechanical stress. In this sensor, the piezoelectric effect is used in certain materials such as quartz to generate rapid electrical signals and measuring the strain upon the sensing mechanism due to pressure. Common types of piezoelectric pressure sensors are charge mode type and low impedance voltage type. Piezoelectric sensors use an element made of a material which generates electrical energy when they are under strain, such as quartz. Crucially, they only produce energy when the pressure changes and are therefore suitable only for dynamic pressure measurements and not static. They are also susceptible to shock and vibrating. Advantage of piezoelectric pressure sensor, it has good frequency response and no need of external power. And disadvantage of the sensor is change in temperature will affect the output and it cannot measure static pressure. Next, piezoresistive pressure sensor. Piezoresistive sensing element can also be arranged in a similar bridge formation. The diagram illustrates how the sensing elements of the bridge type pressure sensor are attached to the flexible diaphragm so that resistance changes according to the magnitude of the diaphragm deflection. The overall linearity of the sensor is dependent on the stability of the diaphragm over the stated measurement range as well as the linearity of the strain gauge or piezoresistive elements. Piezoresistive strain gauge measurements are made using a Wheatstone bridge circuit as shown in figure below. An excitation voltage needs to be provided to the bridge. When there is no strain and all the resistors in the bridge are balanced, then the output will be 0 volts. A change in pressure will cause a change in the resistances in the bridge, resulting in a corresponding output voltage or current. Next and last type of sensor is optical pressure sensor. The pressure moves a diaphragm and the attached opaque vein blocks more of light from the LED. The fall in light intensity is detected by the photodiode and gives a direct measurement of pressure. Advantages and disadvantages of this optical pressure sensor. Because of the amount of movement needed is very small, hysteresis and repeatability errors are very low. The small size and flexibility of fiber optic sensors means they can be deployed in locations that would be hard to access with other techniques. The fact that the sensing element itself is passive and does not need a power supply enables the sensors to be used in a wide range of applications where getting power to the sensor could be a problem. This also eliminates signal transmission problems due to parasitic capacitance, electromagnetic interferences, and so on. On the other hand, their small size can mean they are not as robust as other sensor types. Their high sensitivity can also make them more sensitive to mechanical vibrations. There are various application areas of pressure sensors like pressure sensing, altitude sensing, flow sensing, line or depth sensing. It is used in real time also. Car alarms and traffic cameras use pressure sensors to know whether something is speeding. In touchscreen displays to determine the point of application of pressure and give appropriate directions to the processor. In digital blood pressure monitors and ventilators, it is also used in industry monitoring gases and their partial pressure. It is used in aeroplanes to provide balance between the atmospheric pressure and the control system. It is used to determine the depth of oceans in case of a marine operations to determine suitable operating conditions for the electronic system. So these are the wide application areas of pressure sensors. Thank you.